So Jane, my Remington Model 1100 made in 1985, has become my go-to shotgun for the trap range. And for the first time, I noticed some wear on the O-ring, an important part of the 1100's gas operating system. Always looking for a new direction and a cutting-edge product to test out here at the Millsurp Garage, we visit with some FKM O-rings from Nelson Seals. What is FKM, you ask? Let's find out. Millsurp Garage. So, this gas operated system of the Remington Model 1100 was invented in 1963 and has certainly stood the test of time. I actually believe it to be the best gas operated system ever used on a shotgun. Simple. Not much wear on parts, not many moving parts, easy to replace components if necessary. And while this O-ring might seem vulnerable given its job, they last seemingly forever. But eventually, like anything else, that's a wear item. It may need replacement. Now, the thing about the 1100 is it's called like a self-cleaning design. I'll link I think I got a couple of 1100 videos there. I'll link them down below. Oh, and I'll also link my Sweet Jane. This is Jane, by the way. And I have a Sweet Jane video that is my personal favorite. People have asked before, which is your favorite video? And I never really give an answer, but truth be told, the favorite of all my videos, it's not even one I could monetize because it has music in it, is my Sweet Jane video on going to the trap range with my buddy Mike and shooting. German Mike. So here's the system. The components, at least. I mean, you have basically this is the chamber. Again, it's dirty. I just shot it to test out what we're putting in here. So if it's dirty, which is good, supposedly this thing could go through just many rounds of trap shooting without having to clean it. I clean it every time, but this self-cleaning design it was revolutionary, definitely revolutionary. So you have the chamber here, and then this is basically the piston. This is the part that gets, pressed back by the gas to operate the action. And it's these rings in here that fit inside this chamber that harness the gas. Excellent design. It needs this O-ring right here. You could slide it right off the front of the tube. It needs this O-ring because what that does is it seals the front of it. I wish we could get in here, but we really can't. You could see the gas, the holes that the gas comes from the barrel into this chamber. But trust me when I tell you that in there, see if I'll just attach a photo. But in there, this gasket has to sit up against here, the front of it, just so that gas doesn't come out this way. And so that all the gas gets pushed backwards to operate the action using these rings and stuff. Not friction rings, they're just kind of like gas control rings, let's say. They're kind of like the function like the piston rings in your car. Seals the chamber so that the gas pushes against this, similarly the way when the spark plug detonates the air fuel mixture in an automobile engine, in an internal combustion engine, and it forces the piston down. Same thing. This forces this piston back Um, and it's just like a, just a pulse, just a shot just to get it to be able to operate. And it's this gasket that sits up front. An interesting thing that I found was that you don't have to necessarily get rubber. You could get something called FKM material, fluorocarbon O-rings. So fluorocarbon O-rings offer excellent resistance to chemicals, oil, ozone, and sunlight with a higher temperature range than nitrile, which I'm assuming is rubber, AFLAS, EPDM. You got to be like a chemical engineer to really understand some of this. This is kind of like an industry insider type. It's written for people who know what these things are. But the best thing about these, by the way, I found these on Amazon. These are Nelson seals. You get 10 for $13 to your door with Amazon Prime. So I mean, how could you go wrong there? You'll definitely have that bag of gaskets forever. So the cool thing about these things is they can be used in petroleum oils and fuel, non-flammable hydraulic fuels, acids, aircraft engine applications, synthetic hydraulic fluids, organic solvents, which is good. That's what we use, right? Organic solvents, mineral and vegetable oil, grease, butane, propane, natural gas. The best thing about these things, oh, and then it lists some things that you can't use it with, which, we don't really have to worry about all these things so much. But just from reading, like brake fluid, I don't know if you clean your guns with glycol-based brake fluid, you won't be able to do it with these. I don't think there's anybody out there really doing that. But whatever hydrocarbons, ketones, alkalis, low molecular weight esters and ethers, fireproof hydraulic fluids, don't use those. Or whatever formic and acetic acids are. We're definitely not putting acids on the gun. But what's cool about these things, let's take a look here. This graph. This graph is what says it all. This is what turned me onto it. So what we're concerned with is chemical resistance. We're at excellent. All right. Now, if you're out there in the cold, we'll cover like what temperature range these things work at, but it doesn't really get the greatest rating for cold. But you're thinking, cold, like, hey, I might be out there freezing temperatures, and I'm going to need these things to function without breaking. When they say cold, they're talking about cold. We'll see. We'll get to that. But it's really heat that we have to worry about more than anything else, because while you think it might be cold out there when you're out there in the winter, that's not really that cold. But heat, yeah, if you rapid fire these things, can get pretty hot on that magazine tube. And I'm sure that's one of the main reasons why the rubber gaskets could get messed up, is from heat. These things, heat resistance is excellent. Oil resistance, excellent. Tensile strength, between good and excellent, which is good. We don't want them snapping. Now, abrasion resistance is listed as good. Of course, we would have to worry about abrasion resistance, but it's if the gun is working right, that O-ring, it doesn't really move around much or abrade much. I think you'd worry more about the heat. It's right there where the gas is first entering that chamber. I mean, that's a hot spot. It's heat that we got to worry about most. And I think that's the main thing. See here, we have advantages. These advantages are exactly what we're looking for here. We want resistance to chemicals, oil. We want to be able to use petroleum oils or mineral oils. I use ballistol, so you want even mineral oil to be okay, because ballistol is more of like a non-petroleum oil. Silicone oils are okay. A lot of these gun greases and gun oils have silicone in them, or any kind of grease that you use. Solvents is okay. Water or steam up to 400 degrees Fahrenheit. See, that's the temperature. The operating temperatures are in the normal range up to 400 degrees Fahrenheit. It could go more, but normal to 400 is normal. And then look at this list of like disadvantages. Low operating temperature the limit is negative 15 degrees Fahrenheit. I mean, listen, you might be out there in the cold. I really don't know if you're up there in Alaska somewhere, you got to go below negative 15. But even then, most common formulations of FKM materials operate to negative 15. Special formulations of compounds can work to lower temperatures. So if you look around to see what like a different compound specially made for lower temperatures, if you're going to be out there at like negative 30 or something. The temperature range, normal temperature range is up to 400 degrees Fahrenheit. And the cold to negative 15. Short term, say it's about negative 50 to 490, close to 500. So that's short term. So if it was negative 40 and you needed to go out just to hunt for a short amount of time and come back into the heat, it would probably survive. And if for a short time you really do a whole lot of crazy shooting where you're up around 500 degrees, it'll handle it for a short time. That's what we're looking for. Chemical resistance, heat resistance, oil resistance, all excellent. Will they last forever? No. Are they good for this application? Definitely. So FKM, what could we how can we describe exactly what this stuff is and still maybe, not sound like we're in a chemical factory? Let's see. So Wikipedia has a good article here. It describes it as a family of fluorocarbon-based fluoroelastomer materials defined by ASTM International Standard D1418. So I guess there is like an agency that standardizes these types of O-rings, because I mean they're used for aircraft and stuff. I mean they definitely have to be on top of exactly what these things can and can't handle, because they're used in like very sensitive and important equipment, O-rings, and also, so is that standard, and also there's an ISO standard 1629. They're commonly called fluorine rubber or fluororubber. FKM is an abbreviation of fluorine Kautschuk material. All FKMs contain vinylidene fluoride as the common monomer, to which different other monomers are added for specific types and functionalities fitted the desired application. So this guy here with Nelson Seals here, he figured out a formulation that's perfect for this application, where the temperature range and the abrasion, again, the graphs I just showed you were for just a generic one. But this company, I'm sure, Nelson Seals, I'm sure they're up on every different type of slight variation with these even. So maybe these have even higher abrasion, higher heat resistance. Maybe they're specifically formulated just for this application right here. It was FKM, originally developed by DuPont, of course. Who else? And how interesting for it to be used on a Remington, that DuPont acquired Remington. Even this is in 85. I think DuPont owned Remington during the period when this gun was made. So how awesome is that we're using a product originally developed by them. It was developed under the brand name Viton, now owned by Chemwars. FKMs are today also produced by many other companies, including, wow, there's like 9 companies here that I cannot even begin to pronounce, but they're made by several companies, several Chinese manufacturers. Fluoroelastomers are more expensive than neoprene or nitrile rubber elastomers, but they provide additional heat and chemical resistance. FKMs can be divided into different classes on the basis of either their chemical composition, their fluorine content, or their cross linking mechanism. So there's types too. There's a type 1, 2, 3, 4, 5. And if you want to look on Wikipedia and really break down what these different types do, have at it. And then there's these cross-linking mechanisms used in the curing process of FKMs where they really go into it in depth and what their applications, the properties and the applications. So it says these things are used for petroleum refining, where they're used for seals, pumps, gaskets, and so on due to their resistance to chemicals. Analysis and process instruments, separators, diaphragms, cylindrical fittings, hoops, gaskets, semiconductor manufacturing, food and pharmaceutical because of that low degradation, and also in contact with fluids, aviation, aerospace. High operating temperatures and high altitudes require superior heat and low temperature resistance. I'm looking for where it says something here about guns, but they're talking about watch strap industry because of the resistance to chemicals and temperatures. Can't really see anything. Scuba diving. Yeah, we always fall by the wayside with the whole gun thing. But yeah, here it is, green and looking mean and green, and shot around with it today with Jane right here. I shot a 22 and a 21. So yeah, when you put these together, my advice, just leave it up here. There's like a recess right there. You could just leave it right up there. And when you slide the barrel in, it's just going to kind of eat it up. You just leave it right there so it doesn't have to shove it around too much. You know, when you close the action, it's just going to square everything up in there nice. You know, put a little oil on it, a little bit, and there you go. You got yourself a fluorocarbon gasket. So yeah, let's take a look. Zoom in here a little bit, and we'll take a look at what happened. This is what happens. See it there, right? That's the kind of wear you start to see on the rubber ones. That looks heat damaged, right? Looks burned to me. Well, regardless, we replace them. So, interestingly now, the 1100. By the way, it's often referred to as the first gas-operated semi-auto shotgun because it's made in 1963 is when it was introduced. And by the way, if you're interested in the patent, to check out the patents for this whole system of rings and gaskets and how this gas operation works, the inventors were Kelly, Leak, Martin, Morse, Roberts, and Workman. Bunch of guys all getting together there in the end of 1963, right around Christmas time, filing the patent. And the patent was granted in 1965. The patent is U.S. Patent 3200710. So you go check it out. It's very, very detailed. It's not one of these ones that's incredibly long. It's only a couple of pages. It has a nice diagram of the rings and the gasket. And it has an excellent description of how this gas system works. This was a refinement of the gas system of the Remington Model 58, of which I have a video you can check out. I'll have down below. I'm going to have all the videos for my 1100, the video for my Model 58. Remington Model 58 was the first, gas operation, first Remington gas operated gun, but still not the first. 1956 is when that came out. It had a similar system, but not the same. It did not have this gasket. It's a bit different. Check out the my Model 58 video. I kind of delved into it. It had like a little adjustable thing where you could adjust for high loads and low loads, and it wasn't self-adjusting. The big thing about the 1100 when that system came along is that it was self-adjusting to, it wouldn't matter if you used heavy loads, light loads, it would self-adjust. But the 58 didn't. You kind of had to set like a bleed off valve sort of for the gas to be able to set it up right. But again, not the first gas operated shotgun. Which was the first? You're gonna have to tune in to the next installment of the Millsurp Garage for that information. Go check out the Sweet Jane video I have linked below. And for Nelson Seals, not a sponsor, just a cool product that I found. And Jane and me and Lola say, see you soon.